In the last video, we have discussed about the machine selection in general. In this video, you will learn how to select a CNC turning center for process planning or machine procurement. Happy learning. In my previous video on machine selection, Series 1, I have already indicated the factors to be considered for machine selection. Just for your reference, I am repeating those points here. Or if you want to know the details of this, I request you to watch the Series 1 video. Now let us discuss how to select a CNC turning center. This can be for purchase or this can be for process plan. In this video, I have used catalog from Doosan. So this is x-axis, this is x-axis, and this is z-axis. Now let us have a look at the specification given by the machine manufacturer. Swing over bed. So this is the diameter, maximum diameter, which can be held in the machine without fouling on the bed. So that is the maximum diameter. Now swing over saddle or swing over crossline. This is the maximum diameter which can be held in the part, can run without fouling on the saddle. So what you are seeing in the bracket is in inches. Recommended turning diameter. So you can see there is a huge difference between the recommended turning diameter and the swing over bed and swing over saddle. This we will see in detail in the further slides. Maximum turning diameter. So this is the diameter which can be cut when the part is held between the chuck and the tailstock, and using the standard turning tool. So now we are seeing there are two diameters, one is 350 and another one is 300, because the manufacturer has given two options. One is without live tools and another one is with live tools, where you want to do some small milling on the same machine. So then it will be called a turn mill center. So this option is for with live tool. So now we will mainly concentrate on these options without live tools. So some of the options it will not be even applicable for without live tools, or and vice versa. Now maximum turning length 330 mm, and in bracket you can see another one 550. That is an optional thing. So if you have an extra bed length, then this is applicable. Standard machine will be 330. And then chuck size. Chuck size, this is in inches. So 6 inch or 8 inch, or even it can be other sizes. Bar working diameter. So this is the diameter of the bar which can go within the chuck and spindle. All these points we are going to see in detail. Then travel distance. X-axis how much travel? 205 mm and 8.1 inches. Z-axis how much? So 340 is the standard, and if you go for a extra bed, then it is 560 mm. Then what are the rapid traverse speed rates? X-axis 30 meter per minute, Z-axis 36 meter per minute. Now let us see the spindle details. Spindle speed 6000 revolutions per minute RPM. Spindle motor power, here two different conditions are mentioned. One is Fanuc and other one is Siemens, two alternatives. So if it is Fanuc, it is going to be 15 kilowatt, and if it is going to be Siemens, it is going to be 12.6. And for torque also the same is applied. If it is Fanuc motor, it is 127 Newton meter, and if it is Siemens motor, it is 100.8 Newton meter. Spindle nose is 8 to 5, so there are different sizes. Spindle bearing diameter 90 mm. Spindle inner diameter, so this is what is required when you want to work with bar. C-axis minimum indexing angle. So as I already mentioned to you, this is applicable only for a machine with live tools. Where there is no live tool, this is not applicable. So when you want to do some milling, the C-axis will be controlled. So the rotary axis will be a controlled axis. Now let us see the turret and tailstone. Number of tool stations, so 12 or 10 in this case. There can be turrets with 8 stations also. And the OD tool size. So here you can see there are two options. For without live tools, it is 25 by 25. So the square shank of the OD tool holder. And for with live tools, it is going to be smaller, so 20 square. Maximum ID tool size for the machine without live tools, it is 40 mm. Turret indexing time is 0.11 second. Maximum rotary tool speed is applicable for live tool, so 6000. Rotary tool motor power, Fanuc and Siemens, that is for live tool. Travel distance, taste of travel distance, that is 360 mm. Fuel diameter 65, fuel taper MT4. Now let us see the power source. Power consumption without live tools, it is going to be 24.21, and for the other one also the same. Then come machine dimensions. This is very important when you have a limitation for the space. If you have enough space, it is fine. So in this case, the length is 2.3 meter, width is 1.6 meter, and height is 1.7 meter. Weight is 3 ton. An NC system, NC controller, CNC controller is, there are two options here also. It is Fanuc I Plus and Siemens A28T. Now let us see those things in detail. You can see the chuck is rotating, and the diameter made by this rotation is swing diameter over bed. You can see here is the bed, here there is a cross slide or saddle, and the diameter which can be running just with the bed, that is called swing diameter over bed. Now the thing which can be run over the cross slide, it is called swing diameter over cross slide. Then comes the maximum turning diameter. So you can see for this machine what is there in the catalog. So there is a maximum turning diameter and there is a maximum length. So here there is a chuck and here there is a tailstock which is kept on the maximum side, and with the standard tool what diameter can be turned. So that is what is 350 mm in this case. This is a standard part. This particular machine is with live tools, and the part is held between chuck and tailstock. Now let us have a look at the working range. With the standard OD holder, here you can see different sizes of the spindle. I mean chuck, 6 inch, 8 inch and 10 inch, and this bracket is for long bed. So 340 mm is the Z-axis travel. So this tool can move from this point to this point, and 205 is the X-axis travel. So, and in addition to this, there is one more distance, that is from the center of this to the tool point, 185. So 185 by multiplied by 2 can be the diameter measured at this point where the tool is at the maximum point. So 185 multiplied by 2 can be 370. But definitely you cannot turn a diameter of 370 because the tool has to be lifted up. Some clearance we need to consider. So if we consider say 10 mm clearance, then the diameter would be 3 can be 350 to 360. Now when the tailstock is here in the maximum condition, there is 91 mm clearance, and the tailstock total movement is 360 mm. Now let us see the travel range with different turning holders. So this is with OD holder, standard OD holder, you can see here, and then you can see the place holder here, and you can see the extended OD holder. So these distances are different. So this is 93.5. Here also it is the same, whereas here it is less. So with the facing holder, the start point also will get shifted here, and it can go more inside the chuck. You can see this line is well within, whereas this one is coming here. So this is the maximum cutting length. Now when you are doing an ID operation, so the point is whatever is the length of the bore, that much plus some extra length will be there in the boring tool. So that clearance we must consider. Now spindle. So this is how the spindle will look like. This is the cross section and this is the through hole spindle. Now through bore chuck and spindle. So you can see different chuck sizes will have different bar capacity. For example, in this case, 10-inch chuck, 75 mm bar, and 12-inch chuck, 90 mm bar. So this is how the bar will go inside the chuck. Now let us have a look at the turret. So this turret is a plain turret without any tool mounted onto it. It's a 12 station turret. The same kind of turret with fully loaded tools you can see here. This is the tool holder size. So the OD tool, what is the square shank size? This is 8 station turret. There can be 10 station turret also. So now let us see in a turret what are the holders and accessories to be used. So this is boring sleeve, this is boring bar. So this boring bar will go into this boring sleeve depending upon the size of the boring bar. And then this assembly will go into this. This is a ID tool holder. So a bigger boring bar can directly go into this ID, or it can go with different sleeve sizes. And drill with metric taper, most taper can be used with empty holders, empty sockets. And there are U-drill holders, and this one is extended OD holder. This is phase tool holder. Now let us have a look at the tool interference diagram. So you can see this is how the turret will look like with all boring, turning tool, everything is loaded. So the schematic diagram is this. So here you can see this tool. Now 350 mm maximum turning diameter, that is considering the clearance and other thing. So you can see this tool can move 185 mm from this point to this. But entire 185 mm multiplied by 2 will become 370. But 370 we cannot do as a standard cutting. So 10 mm clearance per side, if we consider, it will be 350 mm. Now let us see the kind of interference. Based on the interference, how the diameter is limited. So this is the recommended diameter of the part. Even though the swing over bed and the swing over saddle is higher, even the maximum turning diameter is higher, but then why still we are using a lower diameter of recommendation? So you can see the movement of this. Chuck is rotating and the tool is coming inside. So you can see now this part diameter is touching onto the adjacent tools. So in a 3D view, if you look at, it will look like this. So you can see this diameter is touching with this tool and this tool. Now spindle power torque diagram. So this is the spindle speed range. Here 60, 100, 376, all these different ranges, and 6000 is the maximum RPM for this particular machine. 6000 RPM. So here we have spindle speed and here we have power. So the relation between the spindle speed and this power. So you can see from 376 RPM when it goes up. So when it is coming continuously, then it is 8.2. 60% it is 9.1. So that is how the power graph. And for torque, you can see with lesser RPM the torque is highest, and then as the spindle speed keep on increasing, the torque remains same for a particular up to a particular RPM. Then it start reducing. So you can see in this case up to 376 it is almost straight. Then 376 to 1500 there is a drop in the torque, but it is not much. It is somewhere around 15 to 20 torque Newton meter difference. But then there is a steep drop, 1500 to 6000 when you go. Reduction in torque is very much there. So from 100 to 15 it is going. And other thing is the controllers. So you can see different controllers in this particular model by the manufacturer. He is giving two alternatives. One is Fanuc and the other one is Siemens. And there can be head and hair also. That is also a available controller in the market leader. Then comes chip conveyor. Based on your machine size and the location where you are fitting it, chip conveyor can be having the chip collection at the rear side or chip collection at the right side.